All right, 13.8, perimeter. So, as discussed throughout the chapter here, the first 7 lessons are kind of their own thing here. Unit conversions is the name of the game. The first 7 there, which we have done at length here. Going through today's homework, you guys, I feel like we're pretty much, most of you are there. You understand how this works now, going which way with the stuff, and it was solid time spent there. Good learning, good growth on this stuff. So now we're going to shift gears here. Perimeter is kind of its own little concept here. Perimeter specifically, well, I'll write out a definition here for you. Perimeter. What exactly is perimeter? So perimeter is the measurement of the exterior sides of a polygon. And we didn't really cover what polygons are. We would have to go back to chapter 10, which we have not done here. But I'll just take a moment here. I'm looking at 10.7 here. Polygon, and you know different polygons here, but polygons are made up of lines, not curvy lines, not, circles. Circles aren't polygons. 3 or more sides, because that's the smallest I can do with lines. A line is just a line. That's not a shape. It's just a line. So, the smallest polygon I could make would be a triangle. 3-sided figure here. All the sides are closed off. Different, it goes on forever and ever here. 4-sided figures are quadrilaterals. 5-sided pentagons. 6-sided hexagons. Heptagons. You can see some of the names of different sided figures here. Not really the point of what we're up to nowadays here, but since we never actually talked about what a polygon is here, this is what a polygon is here. So we'll cover this concept more next year in quite a bit of depth. We'll classify polygons, we'll classify quadrilaterals, we'll name triangles by their angles and sides. So next year we're going to take a big dive into this type of stuff. And in naming, it's not one of the more fun chapters because there's about 150 vocab terms you have to learn. Ask the 7th graders about it. Yeah. So next year is when we really dive into this stuff here. But for now, what do we need to know? Polygons, triangles. We're going to be looking at triangles, rectangles. Parallelograms are 4-sided figures, but separates itself from the circle. Circles are not polygons. Circles, they have their own day up here in 13-12. Circumference is more or less the perimeter of a circle. Talking about this measurement right here. What's the measurement all the way around the circle? Circles, we call it circumference. Polygons, we call it perimeter. So that's the big difference here between them. But outside of the perimeter lesson, then we're really going to start focusing on area. 13.9, area of that. 13.10, area of that. 13.11, area of that. 13.12, and then 13.13, area of that. So we'll be shifting gears. This lesson's kind of different from the other ones here up through 13.13. And then when we get to 13.14, we'll shift gears again, and then we'll start dealing with 3-dimensional stuff there, surface area and volume and things like that, of different types of figures. So this lesson's kind of its own, just, it doesn't necessarily connect to what's going to go on in 13.9 or beyond. So when you think of perimeter, think like a fence around your yard, right? The measurements of that fence around the outskirts of your property there. You can imagine a house here. If this is somebody's yard, and this was a fence here with these measurements, the question would be, well, how long is the fence all the way around? This side plus this side plus this side plus this side. If I had a house here, and again had a fence like this, well, this fence has 1, 2, 3, 4, 5, 6 sides to it, right? See that? 1 side, 2 sides, 3 sides, 4 sides, 5 sides, 6 sides. Agreed? So basically, I'd add up all 6 of those numbers there, and that would be the total distance of my fence all the way around, squares. And we get some funnier looking figures here with a variety of different measurements going on and so on and so forth here. You'll see some odd looking figures. Here's another interesting looking guy over here. We'll probably look at that, figure out how that one works here. But when we're figuring out perimeter, and again, this is the key word here, exterior sides. And I will sketch one out here that illustrates this a little better. None of these do that great of a job except for this one over here. This is the only one that shows an interior side. And we don't measure interior sides, we only measure exterior sides. So I'll create something like this here, and we'll look at it. But when you're finding perimeter, it's more or less an addition problem. And we're going to solve, you see 10, 11, and 12 here. They say, well, now I can tell you what the perimeter is, basically what the sum of these 3 sides is. There's the total. Knowing that, what's the missing side here? I know this plus this plus this equals this. And we'll go through and use some algebra skills to figure out how can we figure out what our missing side is here. So that's what we got. So let's look at number 1. And we have to talk about another thing here. Some of them, I mean, you could probably draw this one. It's not that hard. Okay. And I want to talk about this for a minute here, about what's going on. So first off, how many sides are on this figure?
4.
4. So whatever it is, I'm adding 1, 2, 3, 4 things. And whatever, when I add those 4 things together there, I will get the perimeter. However, there's only 2 numbers provided to me here, right? I got 5 1/10 over here and 7 5/10 over there. So what are the other sides and how do we know what they are? Well, you see these lines here? See those? This one has 1 line over here, there's 1 line here, and then up top there's 2 lines, and there's 2 lines down here. Those lines represent a term called congruency. They are congruent line segments. What do you think congruent means?
They have the same value.
They're the same. Yeah, that's exactly what congruent is. Congruent means it's the same or equal to. They are one and the same. So a lot of times, like with certain figures here, like this one here, trying to write every single side in here is just going to be, it's going to get more confusing than less confusing to have that many values written down next to it. So instead of writing numbers all over the place, we use these congruency, they're called ticks, is what they're called here. And matching ticks have the same measurement, which means any figure, no matter how many you see, like this one has 6 of these little 1 lines all over the place here, right? But every single line tick has the same measurement as the one provided. So what that's telling me here is I see 1 tick here, I see 1 tick here. What that tells me is this is also 7 5/10 meters. All right, this one on the bottom here, though, has 2 ticks. And this one on top also has 2 ticks. And anything that has 2 ticks, again, is congruent to anything that has 2 ticks. So I know on the top, that's 5 1/10 meters. I know this one down here is also 5 1/10 meters because they both have those 2 ticks going on there. there's no limit to how many ticks there could be. I mean, I could have, if I have a third line that has congruency, then I'd have 3 ticks and then match up anything with 3 ticks to that measurement, so on and so forth. Here, we certainly won't see anything bigger than 3 ticks on a quiz or test, but very, very well may see some things with 3 ticks. I think I draw some interesting figures for you on your quiz and test. So got a little zany with it. Sorry, but you know, a little more fun here. You get a couple softballs these too, but you'll also have a couple that are somewhat a little more engaging for you. So there we go. Now I know all my measurements here. 2 were provided to me. I used my information about geometry, about these ticks. What do they mean? What does that represent to me to fill in the remaining measurements here? And now to solve this here, I can just add up the 4 values. It doesn't really matter the order I add them. 1 plus 2 plus 3 is the same thing as 3 plus 2 plus 1. So the order you add stuff doesn't matter. You could use multiplying if you want. I could certainly just know that, well, there's 2 of them that have that measurement, and there's 2 of them that have that measurement, and then just add up the, done. Don't need that. I could certainly just add those 2 products together. Don't really care how you go about solving it, to be honest with you. If you want to add 4 numbers or multiply and then add, that's fine too. Whatever's easier for you. But what's the perimeter of this polygon?
25 and 2/10.
Right, 25 and 2/10 is what you should come up with here. And again, I can get there either just one time. I can just add them up. Doesn't matter the order. That one plus that one plus that one plus that one. There's my 25 and 2/10. Or if I use multiplying, there are 2 of them with that, so I'd just probably write that number down off to the side. Do the same thing with the other one, 2 of those. That's 15, and then just add the 2 values together. That gets me there too. So, different ones, and you know, whatever works for you there. One thing I want to tell you as you get into the homework, quiz, and test. Looking at your homework here, I see some with fractions. I don't see any with decimals. This one had decimals, this one has fractions, so pay attention to this here. This is important for your quiz and test. So when you're representing your final answer to me, if the information is provided to you in decimal form, your final answer should be in decimal form. If the information is provided to you in fraction form, your final answer should be in fraction form. So whatever form you see, they're not going to have some decimal, it'll be one or the other. But whatever the form used or whatever type of measurements being utilized is the same type of measurement you will use in your final answer. Don't convert to whatever you feel like converting to. Mainly, don't convert your fractions to decimals. If it's not already in decimal form, I don't want it. If it's in fraction, I want a fraction answer. Unless it's a whole number, of course, obviously. But decimals, decimal answer, fractions, fraction answer. Make sense?
Yes.
Okay. Number 2. If you want to sketch it, all the power to you. It's a 6-sided figure, though,
I'm gonna sketch it.
called a hexagon.
4, 5, 6.
So,
Oh my gosh, that looks ugly. How did you draw it so good?
math teacher skills. Good at drawing different figures.
I did like,
So, take some practice.
I
But,
did an octagon, not a hexagon. Holy crap.
8-sided figure. So again, it's not art class. If sketching it's not working for you, then whatever you need to do here. But
It kind of did it. I mean, it's kind of ugly. But
so pay attention to your labels throughout the rest of this chapter. For now, we're just adding things here. So all your labels are just in whatever the label is. This was 25 and 2/10 meters. We're just adding things together. My answer for this one will be represented in centimeters. But before we're done here, we're going to have units in normal units like this. We're going to have square units, and we're going to have cubed units. We're going to have 3 different type of units going on here, depending on what type of problem you're answering and what type of figure it is. So you will need to have the correct type of unit representation on your quiz and test. You'll want to really focus on your units. Right now, we don't really have a lot to worry about, but understand perimeter is merely the sum of different things. If I add up a fence, again, it's not square units. Square units deal with the area inside of the perimeter. This is where the area is going to be found inside here. And different figures have different formulas. We'll cover that in later lessons here, but that'll be measured in square units, and I'll show you how that works here. But just pay attention to your units here. They're a big deal. With geometry stuff there, it matters quite a bit what you're signifying and how you represent. This type of stuff here, geometry is very technical, very specific. There's a lot of symbols involved. Again, if you talk to Sam or whatever, he can see his test, you'll understand here. It's very, very specific. So we're not doing that much this year. Next year, though, we'll take a big, deep dive into it. 8th grade, too, we'll take it a step further. So we have other things to do in 6th grade. So anybody, what do you think my perimeter of this hexagon is?
27 and 6/10.
27 and 6/10. How'd you get that?
I did 4 and 6/10 times 6.
Yeah, and that's probably what I would do too. I mean, you could certainly go 4.6 plus 4.6 plus and do that 6 times, but you should also be able to recognize that it's just multiplying is basically just expanded addition. So, but whatever you chose to do here, if you added them all up here, I guess that's your choice. I'll write it out one more time. You certainly could sit around and punch all this in to get there. Whatever works for you. As long as you get 27 and 6/10, we're in good shape here, but I would hope by this level this is how you would solve it. Just much more faster and efficient, right? Great. Sometimes they give them in this weird form here, which is fine. So what this S means here is the side length of a square. It's saying that all regular figures are considered perfect figures where all sides are congruent. Just for you don't have to write this down here, but if I say a pentagon, most likely you think of something like this, right? Like in Washington, D.C.
Oh, yeah.
A pentagon is a 5-sided, but that's what you would think of, right? But the truth is, I could do that right there, 5 sides, that's also a pentagon. They're both pentagons. You may not think that's a pentagon, but it is a pentagon. A pentagon is defined by how many sides it has, not its shape. Any 5-sided figure is called a pentagon. Right. And as long as it has 5 sides, congratulations, you drew a pentagon. So a regular pentagon, though, would be more like this. A regular figure means all the sides are congruent. Like a square. We know what a square is. All 4 sides are the same measurement there. But that would be a regular 4-sided or a perfect quadrilateral, essentially. So this would be regular, perfect, so on and so forth there. I won't ask you things like this here, not the heptagon and square. The rectangle, perhaps, I would hope you understand what a rectangle is.
I hope you
Length and width. Rectangles are defined by 2 sets of parallel sides that are congruent and 4 right angles, lest you wonder about that there. But anyway, number 3. What's the perimeter? And they truly classify it as a square for us by 4 congruent sides, 4 right angles. Notice that that's 20 1/3, so I would be looking for some sort of fractional answer spit back to me here. 20 1/3. Anybody, what is it?
60, no, 80 and 1/3.
Not
81
quite.
and 1/3.
81 1/3.
Wait, how do you so dusty?
So how I would set it up, again, we've covered this multiple times before, but turn it into an improper fraction, 60 1/3, and then I'm just multiplying that times 4. 61 times 4 is 224 over 3. 224 divided by 3 is 81 with the remainder of 1, or 81 1/3.
Wait, how do you know how to multiply by 4 again?
Because there's 4 sides. I'm multiplying 20 1/3 times 4. 1, 2, 3, 4.
That makes sense.
Or it's 61, or it's 20 1/3 plus 20 1/3 plus 20 1/3 plus 20 1/3. But 1/3, 1/3, 1/3, and 1/3 is 4/3, right? 20, 20, 20, and 20 is, so now you would have 80 and 4/3. But 4/3 is just 1 1/3, so 80 plus 1 1/3 is, you can do it that way too. Just set up the adding problem. If it's easier this way for you, do it like that. Add the fractions, 1/3, 1/3, 1/3, 1/3, 20, 20, 20, 20, 80 and 4/3. Simplify back to 81, right? As an addition problem, right? Make sense? Okay. Why don't you guys try number 7?
Oh, I already did that one, bro.
Well, cool.
I did that at the beginning of the lesson.
I'm not gonna draw it. I wouldn't suggest drawing it. It's gonna take a little bit of time here. I guess if you really want to, I mean, I could, but we don't need to spend 90 seconds trying to recreate the figure. So, using what you know about congruency and all that, how many sides are there?
1, 2, 3, 4, 5, 6, 7, 8.
8. There's 8 sides.
Yeah. 1, 2, 3, 4, 5, 6, 7, 8.
How many of them have a measurement of 5 inches?
4.
4. How many of them have a measurement of 3 inches? 3. Or 4.
Oh my gosh.
4.
Oh, same thing.
4 of them have a measurement of 3 inches. So in your head, what's 5 times 4? What's 3 times 4?
12.
What's 20 plus 12? And there's your answer. There's your perimeter.
I got that.
Right.
Did you get it wrong because you did it before the lesson? Yeah.
32 inches. So, and of course, you could, if you really wanted, you could sit there, or whatever order you want to do them. I mean, I don't know, but, or whatever you see there. It's the sum of those 8 numbers. You can add them up one by one if you want. That's fine. Try number 8.
Can we do number 9 because I don't really get it.
We'll get there.
The sides aren't named.
Yep, we'll get there.
You are not named.
What? How come my name's
So
wrong?
try number 8.
Oh, man.
Okay.
Oh.
Eye is just dead. Your eye is just dead.
So I will draw this one out just to try and help a little bit with it.
Same. 1 second.
So how many sides are there?
It's not changing. 6.
6 sides. 4 of them are provided to me. So the question is, what is that and what is that?
6 meters.
And how do I know?
Because the 6 meters is the exact same length as both of them.
All right, let's start with this one right here. So what do we think that is?
6 meters.
6 meters?
Yeah.
Why?
Because it's the exact same length as the other 6 meter one.
That's using your eyes here. You don't want to trust your
Right
eyes here.
angle.
There are right angles, but again, there's levels of congruency here. Opposite sides are parallel. Opposite sides have the same measurement.
Because 6 plus 6 equals 12.
Right, because the total from here to here, we know on top is 12, right?
Oh,
Right? You see that there? From here to here, it's 12. So from here to here is 6, and then from here to here, basically it's a subtraction. 12 minus 6 is
Oh my
6.
gosh, that makes sense.
Right, so that's 6 meters right there. What's this one right here?
6 meters.
6 also.
Because the side to side 8.
Well, some people say 4, some people say 6. So how do you know? Prove it.
Because
4 because it's good.
6 plus 4.
wait, no, it is
Actually,
4
no.
because it's
Yeah.
8 meters up
Oh,
and
yeah.
down.
40.
Same concept applies that we just did on top. From here to here is 12 meters, meaning from here to here is also. Because again, we're not figuring this area right here, but if I completed it here, I'd basically make a 12 by 8 rectangle, essentially is what I would have here. But from here to here is 6, from here to here is also 6. But now on the other side, here to here is 4, but from top to bottom, it's 8 meters tall, right? So from here to here is 4. What's here to here? What is it?
4.
Is 4, because 4 plus this 4 gives me my 8 total on the other side here. Right. So this is 4 meters right here. That's 4 meters right there. That one's 6 meters. Now, go ahead and find the perimeter.
38.
40. 40. 40. 40.
I got 32.
40, bro. I only got one in the beginning because
40 is correct. 6 plus 4 is 10. 12 and 8 is 20. There's 30. 6 and 4 is another 10. 10 plus 10 plus 20 is 40. Use my 10 families to bring that one home there. Number 9's a little unclear to me, to be honest with you.
Stupid.
So I'm going to leave that one alone here just because there's not really enough. I don't know if 4 inches pertains to the left, the right. It's difficult to work that one out, so it's just not well written, to be honest with you. The book says it's 58 inches, but again, it's a little unclear to me. So I'm going to draw another one here just to see what you guys can do with this here. So give me a minute here.
okay, so we need to start.
Give me a second here. I'm just
Oh my gosh, he's cooking. What is that? It's a timer.
okay. So there it is. I'm going to tell you that this is 16 feet. I'll tell you these are all 8 feet. And I'll tell you these are 10 feet right here.
Wait, it'd be weird, bro.
The middle ones don't matter.
Yeah. Yeah, on the outside. That's what I want it to be, though.
You are exactly right on that one. So what is the perimeter?
Oh, okay.
Here's my question to you here. Oh, sorry, these should be 3 ticks here. There we go.
Yeah, oh.
So what is the perimeter?
I'm gonna
There.
start. 6.
I'll calculate. What's cheating?
Using your resources.
Nope.
Do you do the one in the middle?
No.
Yeah, I can do that.
What did you get?
It's weird. Let's do it.
You know that those ones going up, it's not 8, it's 18. Oh, that's
So
18.
I provide you 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different measurements. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10
Are
different.
those 8 or 18?
Yeah, 8.
This is 8.
Oh,
Sorry. 8. 8.
That makes sense.
I got
Sorry, that's my congruency tick there. That's what you're, right. It's supposed to be 8, and that's the 2 congruency ticks across there. So you know 10 different measurements here. But how many sides are actually on this figure?
6.
There's only 6, right? So I don't need all these measurements here. Because again, just like a fence here, it's only the measurement of the exterior. So this, and this have absolutely no bearing whatsoever on the perimeter at all. Those are interior side lengths. So to figure it out here, there's 2 of them that are that, 8 of them that are that, or 2 of them and 2 of them that are that. 32, 16, and 20 gives me a grand total of 68 feet.
Oh, let's lay out. No.
Okay, try this one
Yeah, 6.
right there.
Wait, is this the 3D figure?
Nope, what's the perimeter?
Okay.
What is that?
Well, it's
That's in the book.
no, it's kind of
Where?
I took different numbers though.
Yeah.
Similar, but yeah, it's a good one there,
Wait,
so
is this in the book? Yeah.
kind of, but different, so.
What's going on here? I can barely draw this. Okay. But what's that top number?
15 inches, 8 inches, 4 inches.
Oh my gosh. This is a hard one.
I will work it out myself here.
Oh, delete. Plus 10.
Oh.
Plus. No way, bro.
Wait.
Well, it's 15.
Wait,
I almost comprehended it.
Is that 15 or not?
It's
15? Jeez. So, oh yeah, that's 7. Between that and, oh yeah.
Okay.
All right, I think I got it here.
Nope.
And then we'll look at our last part here.
What'd you get?
All right, we all got something?
Yeah.
All right, where should we start? Savannah, what do you think?
I got 70.
70? Sierra?
37.
37? Evangeline?
66.
66? Brooke?
66.
66? Jackson?
54.
54? Sig?
46.
46? Dom?
51. Oh my god.
All
Is
right.
there a right answer up there?
None of those are my answer.
What?
So, how many different measurements are we gonna have here?
7.
Wait.
Well, different.
Three.
Oh,
Well, how many different numbers should we add together? Here, let's call it that way here.
4.
7.
Well, it's actually,
10.
it's actually
I see what
50.
you mean.
It's 50.
Well, let's count them out here. I'll start over here. 1, need to add that, right? 1, 2, 3, 4, 5, 6, 7, and then whatever that is, 8. So there should be 8 different values going on here.
Number to 50.
And
Not what I got.
7 of the values I know. Because I know this is 4, I know that's 4, and I know that's 8, and I know that's 8 too. So I got 4 times 3, there's 12. I got 8 times 3, that's 24. I got the 15, and then the million-dollar question is, what's that piece right there for a measurement? So do you agree with the 7 measurements that I got here?
Yeah.
1, 2, 3, 4, 5, 6, 7. This one we don't care about because that's an interior
That's inside.
measurement.
Same with the
It's-
other
right,
one.
that's interior. But this piece right here is exterior. And how can we figure out what it is? Anybody have an
15 minus
idea?
4. No. 15 minus 12. Your
Right.
thing is really weird.
I know.
15 minus 12.
Let me just rewrite this
No.
figure right.
Nope.
Just this one
It's 11.
figure. All right, I know that this is 15, I know this is 8, that has to be 15, that has to be 8 too. Again, I'm only taking, I just wrote just this one figure right here, right? Okay, by definition, I mean, these are congruent to each other. So I know from here to here is how long?
15.
It's 15,
Minus 4.
minus the 4, which means this has to be, what?
11.
Yeah, it has to be 11 inches right there. That's the 8th side right there. 36 plus 30, 26, 36 and 26 is 72.
I was the closest.
How,
Right.
how do you get the 8 for that triangle bit? Is 4 inches.
It's marked congruent symbols here.
No,
I didn't use the numbers in the book. I made my own. I didn't need you just to look in the book and just go, oh, well, the answer is obviously 38. So I made up different numbers. I used the same figure design, but I made up different numbers. Right, because that would have been more fun. Right. But there are 8 different numbers I have to consider here. 1, 2, 3, 4, 5, 6, 7, and this piece right here. I have to figure that one out on my own. This one I don't care about. It's an internal length. This one I don't care about either. It's also an internal side. So those sides don't matter.
But if you did count that
I
one,
mean,
it would be.
right, those sides don't matter. So again, once I break it down this way, it's a little easier to see the figure, but what do I know to be true about this bottom side? I know from here to here is 4. This 8 has nothing at all to do with figuring out this missing measurement there. It's about just looking at just this parallelogram here and then using what you know to fill in that missing piece there. Eh?
Yeah.
Okay. Last part here. Number 10. So now we're going to go the other direction. We're already going to know the perimeter of the figure here. The question is, what is the missing side length? So, number 10.
This is easy. Yeah, just add them up and subtract.
That's exactly what you're going to do. But I'm going to set it up algebraically, and we'll use our algebra skills to solve here.
Do we have to?
You should, because things are going to get more intense throughout this chapter here. This is, again, dribbling. You're going to be able to dribble the ball before you can gun 3-pointers all over the court. So, learning how to set up these equations, right now it's real easy. This is the beginning of, but this gets very complex not necessarily this year, but it will get pretty complex. By the time we get to the three-dimensional stuff, we'll be having some pretty zany situations going on here. Much longer equations. So getting comfortable about using your algebra skills that we have learned, we've done all four orders of operations here, is a trademark of how you're going to have to solve higher level geometry stuff and how we're going to be solving things going forward here. We're not just going to be finding area of stuff, we're going to be finding missing side lengths of things here. So I believe we will, right? Are we? Or are we just finding area this year? Well, maybe we're just solving for it. Okay, so perimeter is sum of the sides. So if I set this up algebraically here, perimeter equals sum of sides. And I know the perimeter, just plug it in, 22 8/10 equals side 1 plus side 2 plus, I'm just going to call it n. That's what I'm solving for here. I'm trying to figure out the side length. Setting it up algebraically. And you should solve it algebraically. Again, you look over, where do they do it there? Do they do something like this? Right. This very first one they set up over here, you see this one, they're saying, well, what's that missing side here? It's telling you the perimeters, 54 6/10. How did they set it up? Side 1, side 2, side 3, side 4. That's what I don't know. That's my variable. That's what I'm solving for. Equals the perimeter. So this is the setup you want to use here. Set it up algebraically. But now that I've set it up algebraically, what would I want to do next?
You add the two.
Combine your like terms. This right here, I can do right now. I can combine those terms together. 22 8/10, 7 8/10 plus 8 is 15 8/10, still plus n. Now what do I do?
You subtract.
Right. Undo things. What am I doing to n? I'm adding in 15 8/10 to it. How do I undo that? I do the opposite. The opposite of adding 15 8/10 is subtracting 15 8/10 from both sides. That's gone. Now the variable is isolated all by itself. My solution indeed is 22 8/10 minus 15 8/10. The solution is 7 feet. Solved using algebra. Right. So set up the equation, define your variable, and then begin to solve it. Combine your like terms, and then ultimately undo your addition by using your subtraction skills to solve it here. Things will get more intense. So I'll give you one more, and then I think we're at the end here. So jamming in up here.
Which number?
How about number 11?
Oh my gosh, how am I supposed to draw that? You don't have to.
Doesn't have to be
Why would I
perfect,
not
but
draw it though? Like, it's just
oh, there you go. Just kind of like that. So
says the duck.
Says the dust. Yes.
That's not even a word.
and I can tell you the perimeter is 23 and where's the perimeter over here? Perimeter is 23 and 1/10 inch. Right there. There's your perimeter.
Why did you insert when you're lying to yourself? To make
Set up an algebraic equation to solve for y.
Why? Why?
Because you're getting fundamental practice here. You're going to set up countless things algebraically here the rest of this chapter. If you're not, you're taking shortcuts, and that there's a price to pay down the road for
Can
that
I
here.
tell you what I did for my algebraic thing?
Well, it should be 3 numbers plus y equals 23 and 1/10.
That's what I did.
Right. Then you'll combine your like terms. And then and only then will you do your subtraction portion to solve. I won't necessarily hold you to the fire this year, but you can ask the 7th and 8th graders how it works with them, where if the answer is half credit. Setting up the equation's the other half, which works both ways. As long as you make an attempt to set up an equation on your quiz, you'll get half the point, even if you get it wrong, even if it's all wrong. As long as you establish something that looks like the right equation on some level there, then I'll give you half credit for that. So it kind of works both ways. But if you just go right to the answer and just solve it however you want to solve it, well, you'll lose half a point. I'll say show work. So that starts next year when I'll start digging in for that type of stuff, and it's always a battle with some. But usually by the end, most of them get it. 7th grade got the talk again today about it, a couple of them. One of them in particular.
Sam?
Yeah, 2 of them put a big frown on my face today. So. But they understand. They know what's up. And they won't dispute that they're just being lazy. That's what it comes down to.
Well, yeah.
Let's get rid of. Yeah, that, again, they won't dispute it at all that they're just being lazy. So they know how to do it. It's just they don't want to do it. So not knowing how to do it and not choosing to do it are very different things there. But this is the equation. Again, we're not.
3.1 equals 6.5 plus 8.6.
Yeah, if you got 23.1 on this side and then the variable can be on the other side. That's perfectly okay there. I assure you the rest of the chapter we're not going to be writing this much stuff out here. So with our equations, it'll be more condensed, but still just the right form. So now we'll go ahead, combine our like terms that we have here. So 6 and 5/10 plus 8 and 6/10 plus 2 and 8/10. Looks like I get 17 and 9/10 plus whatever my variable is. I guess it's y, but whatever. Equals that. And then ultimately to finish it, undo my addition. Opposite of addition, subtraction. Subtract from both sides. And then my final answer lies in 23 1/10 minus 17 and 9/10, 5 and 2/10 inches. Yes?
Yeah.
Okay.
I got one.
All right, you got some interesting figures here in your homework, by the way. And you also have 1,
Here's my book.
2 of them, and both your word problems. So you have 4 problems that involve fraction work.
No.
Right.
I'm coming to Florida and I will find you.
He's finding them. Okay, there we go.
We almost